66 million years ago, something from space slammed into Mexico's Yucatan Peninsula, and it caused a mass extinction. The Chicxulub impact killed 75% of life on Earth and ended the reign of the dinosaurs.
I think we kind of identify with those dinosaurs. They reigned the Earth for 100 million years, and then they were gone. Could that happen to us?
Dr. David Kring is a senior scientist at the Lunar and Planetary Institute in Houston, Texas. It's managed by the university's Space Research Association. The planetary geologist was on the team that first identified the crater from this impact.
In Haiti, we found a very large, nearly half-meter thick deposit of impact debris that had been ejected from the crater. That deposit told us that somewhere in the Gulf of Mexico was where the impact occurred.
Dr. Mark Boslow is a physicist at the Los Alamos National Laboratories in New Mexico and a professor at the University of New Mexico. He's an expert on cosmic impacts and airbursts.
Impact craters on the Earth are generally a lot bigger than the asteroid that created them. The crater can be something like 8 times the diameter of the asteroid, or it can be up to 16 times the diameter of the asteroid.
At the time of the Chicxulub impact, Earth's geography was slightly different.
Sea levels were generally higher. Today, when you actually draw a circle on the map of where the Chicxulub crater is, it appears to be straddling the coastline of the Yucatan Peninsula. But the Yucatan Peninsula was completely submerged at the time of the impact. That means that areas in Texas were also underwater.
Because the crater is underwater, and because natural processes have further concealed it, determining the size of the impactor that created it wasn't easy.
And so today it is completely buried. We have to drill about 1 kilometer beneath the surface before we reach the impact crater.
It was revealed that the Chicxulub Crater is approximately 110 miles wide, and that the Chicxulub asteroid was about 6 miles across. Mark Boslow has created some of the most revealing simulations of an impact.
When we do a simulation of an impact on the surface of the Earth, the composition of the impactor determines whether it breaks up in the atmosphere or whether it hits the surface.
The asteroid displaces the air in front of itself, creating a hole in the atmosphere.
And that creates a plasma, and that plasma is hot and it radiates light and heat, and that actually heats up the asteroid and causes it to vaporize.
One big asteroid impact can change our planet forever, as it did then.
When an impacting object hits the Earth's surface, it's moving very fast. It can vaporize a portion of the Earth's crust, as well as the object itself, and jack it up to superheated temperatures, to a plasma. So this material might reach temperatures of, say, 10,000 degrees. This is the temperatures that we normally associate with the sun.
Before the air can rush back in, vaporized rock is ejected 60 miles skyward. That's more than 10 times the height of Mount Everest. Next, an impact of this size produces tsunami waves at least 300 feet tall.
Tsunamis that radiated across the Gulf of Mexico, right over the area that we now call Houston, and penetrated far inland, halfway to Dallas at least.
as the tsunamis flood the land. The vaporized asteroid continues to displace air and water. Choking hot dust thickens the skies. And fires erupt wherever there are trees.
Something on the order of 10 trillion metric tons of material came raining back down through the atmosphere.
The Chicxulub asteroid was unstoppable. And if a similar one hit today, we'd be in big trouble.
I wish I could say how humans would fare in an impact on the order of Chicxulub. I doubt if they would fare any better than the dinosaurs.
Over the last 600 million years, Earth's been hit more than 60 times by space rocks, at least 3 miles in diameter. Tons of space rocks hit us daily, dust-sized mostly, and they do no damage. But when impactors get large and punch through the atmosphere to reach Earth's surface, then Houston's got a problem. Today, the port of Chicxulub Puerto lies almost exactly at the geographic center of the crater. If an asteroid or comet hit the same place today, the tiny town would instantly vanish, as though it never existed. When a 6-mile wide impactor, traveling at perhaps 35,000 miles per hour, hits a solid target, the kinetic energy is measured in megatons.
Chicxulub impactor had a kinetic energy, we think, of about 100 million megatons. The earliest atomic bombs that were developed by the Manhattan Project and set off here in New Mexico were 10 to 20 kilotons. So we're talking about 10 billion atomic bombs all going off at once.
The bomb that decimated Hiroshima in 1945 destroyed reinforced concrete buildings up to a half a mile from ground zero. That's the damage from an asteroid, only as large as an average-sized house. The Chicxulub impactor was 120 city blocks across. If one hit in the same place today, everything within a 1,500-mile radius would instantly be destroyed, including Houston.
So if that impact event were to occur today in a similar water setting, those same types of tsunamis would be generated. In the vicinity of Houston, the tsunamis might be 50 meters, 100 meters high, and that is a big wave.
With skyscrapers that reach 200 meters tall, a wave of this magnitude would climb as high as 50 stories and wipe out the city.
I invite anybody to step outside their home and imagine a wall of water 100 meters high sweeping through their neighborhood. And it has global consequences, which, as the name implies, has an effect everywhere else on the world.
Within the first 12 to 24 hours, Earth's global atmosphere will approach the temperature of a microwave oven. This happens with a big impact, whether it hits the ground or not.
But if it explodes in the atmosphere, it still does damage to the surface. It can still wipe out a city. It can still hurt people. And if it's big enough, it just completely vaporizes and incinerates everything in its path. That's what an airburst can do.
Dust and debris obscure the sun. So across the globe, plants that rely on photosynthesis will die. Temperatures quickly drop by at least 40 degrees worldwide. An asteroid this size kickstarts an ice age, a large impact also causes earthquakes.
The blast wave hits the ground, and that causes the ground to shake.
Rock layers will be pulverized. Buildings and highways will disintegrate. If we had advanced warning, people would crowd into the deepest available spaces in their towns or cities. Safe underground for a brief window. But regardless of where it hits, 95% of the world's population will be dead within 24 hours from one or more effects of the aftermath. If tomorrow's asteroid hits the Yucatan again, and not elsewhere, the catastrophe will be magnified. Scientists discovered that the target rocks at Chicxulub contain large amounts of sulfur. Sulfur in the asteroid combines with sulfur in the ground to create a particularly toxic soup when it rains. Greenhouse warming gases will remain in the atmosphere for decades, or even centuries. Without plants and plankton to maintain a balance, carbon dioxide levels increase further. For this global catastrophe to occur today, we wouldn't need a monster asteroid. Even a much smaller impactor would be disastrous for us.
The greatest risk is actually in the smaller ones, the ones that are going to kill a few people, the ones that might wipe out a city, the small ones, and that's because there's so many more of them. They're so much more probable.
It's impossible to predict where an asteroid will hit, how large it will be, and what it will mean to us. But with nearly 800,000 asteroids identified in our solar system, the experts say it's not a question of if we'll be hit again, but when.
Because we have a very limited time window in which to come together and minimize the damage to us and prevent a global catastrophe. We think of planetary defense as just mitigation, as deflecting an asteroid that may be on a collision course, but it's also preparing for one that we don't expect, that we don't see coming, or we don't see coming until the very last minute.
We may have ideas of what lurks out there, but it would be folly to say that we know what lurks there.
If we discover something a few days before impact, well, it's on its final approach. It's on its, what we call, death plunge. We can't deflect it. There's nothing we can do about it.
NASA and organizations around the world vigilantly watch the skies for any potential threats. Some asteroids are so dark that they're nearly invisible. Solutions to a future impact are still in the theoretical stage. However, they all require some advance warning. One audacious idea: flying a spacecraft at full speed right into an asteroid. The force of the impact would then deviate the object a few centimeters, enough to potentially change its trajectory and allow it to fly right past Earth.
We now understand impact cratering processes can alter not only the geologic evolution of Earth, but the biologic evolution of planet Earth.
In the meantime, the vast crater in Mexico is a reminder of both our fragility and our ability to solve even the most insurmountable problems.